Hi everyone, in this video we're going to look at Kognitio and how to get going once that you have an instance up and running. Some of you might have looked at the EMR installation video previously, so we're going to start from that point. But what I'm going to go through today is also relevant for Kognitio standalone and Kognitio on Hadoop, and is aimed to tell you how to get the most out of your Kognitio instance. So first thing we're going to do is we're going to, using Kognitio Console, which is one of the client tools that's available, we're going to connect through to the EMR cluster. So here we can see that we're connected to the system in EMR, and I just have a double click on the system here to see what's available to us, and we can see that we've got our 16 nodes set up as you saw in the previous video, and also we've got 3.5 near enough terabytes of RAM available in this system. So when you've got Kognitio up and running, the first thing that's worthwhile doing is probably creating a user to run all of your commands, etc. But I'm going to go straight ahead and just create a schema today and run everything as the sys user. So if I just create a new schema, we're going to look at some retail data. So I'm going to call this demo ret and go from there. And we're going to create all of our objects and views and images within this demo ret schema and not within the sys schema, which is where we hold all of the metadata for Kognitio. So with EMR and often with Hadoop systems, you might want to connect to data that's external to Kognitio. For EMR, the obvious place of choice to store data is in S3. Now this is the S3 bucket Kognitio EU, and you can see here we've got some demo data, and if we just navigate through the folders, we can see that we've got a whole series of files here that is electronic point of sale data for different stores, and also a few lookups. We've got some store lookups, some product lookups, etc. So what we're going to do today is we're going to create a connector through to S3 from Kognitio, and we're going to create some external tables that point at these files that allow us to then extract this data, hold it in Kognitio memory, and run some queries over it. Okay, so within Kognitio, the first thing you have to do in order to connect to S3 is to create a connector. You can see here that with Kognitio on Hadoop, you get a default connector for HDFS and MapReduce. I'm just going to go quickly ahead and create one now for Amazon S3. So let's just paste some code in. Okay, so Kognitio comes with a series of modules pre-packaged that are easy to install via the create module command, and the AWS one is the one that you want for S3. So we can just step through and create that module, and you'll see that that's under the plugins section. We can see here. Now this is grayed out, so that means that it's not currently active. So we can just activate the module. And then in order to control who's allowed to use this particular module in order to get to data, then we'll create a group as well that's associated with it. And we can also then start to create connectors that link through to our data within S3. So we can see here, there's the bucket that we had a quick look at in S3, and here's the access key and also the secret key associated with that. And you'll have set the rules up on there to allow data to be read from S3 within the AWS management console. We also limit the number of connectors per node, but this allows for lots of parallelism. So we've got 16 nodes and we're allowing 5 connectors per node, and that'll allow us to ingest the data nice and fast from S3. So we just create that connector through. If I just update here on the left, we can see here's the AWS connector ready for us to use, and then we just want to grant any users that we want to pop into the AWS group the ability to use that to connect. So that's the connector set up. Once the connector's set up, we want to start getting to the data. Okay, we want to create some tables, and in Kognitio, Tables that come from sources that are external to Kognitio are known as external tables, and you'll see that the syntax to create these is very, very similar to the normal syntax for a create table in SQL, the difference being that there's this additional line at the bottom here. Now we've created the AWS connector, so this is what's going to be used to find this external table information, and then we simply state a target file which is identical to the file path within the S3 bucket that we saw previously. So what we're doing here is we're creating some retail sale data with a series of fields and types that are originating from a series of CVS files within that S3 bucket that match this particular wildcard. So this is going to connect through to a number of files. This is useful because what we can do is we can have the connecting to a place where data is incrementally added, and as more files are added, they will simply be picked up by the external table connection. So let's go ahead and execute that step. Okay, so there we go, and if we just refresh here, we can see that this TRET sale table has appeared in the demo retail, and it's indicated as a red file with an X to indicate that it's from an external source. I'm just going to go ahead and quickly run through the rest that are connecting through to various other lookup tables within the data. Okay, so there we are. So if I just refresh here again, we can see now here are our different tables ready for us to access. And we can test these very simply. If I just run a new query, perhaps I might want to look at the product lookup table, and let's just select the top 20 rows from that and just execute there. We can see that here's the information passed in, and it's in tabular form as defined inside of the external table creation statement. So we're ready to go with the data. Now, currently the data is residing in S3. In order to get excellent performance from Kognitio, the best thing to do is to pull these data sources into memory and pin them as images within that memory. So I'm going to go ahead now and take the next step. And the way that we tend to do this is to create a series of views off of these data sources, off of these external tables, and then image those views. So let's concentrate first on the main sale data. So I'll just click through to this SQL here. The most straightforward way that you can create a view in Kognitio is simply to select a copy of the data that's within the external table, and just do a simple select star. This is fine if your data is already in a clean format. You can just go ahead and create a view that sits off of that. So let's do that for sale data. If you want to get a little bit more creative with what you do in terms of the view creation that you submit, it can be any SQL query inside of here, so it can be as complicated as you want. Here we're just adding a simple extra field to allow us to do a lookup of all the stores if we want to at some point in the future. So we can go ahead and create that. We've got a product hierarchy, which is department, group and section. Again, we want a top level in the department. So similarly to stores, away we go. The group table's straightforward. Here we're doing a compound key because section number is not unique outside of each group. So we just create a simple compound key there. And then finally, we've got the product view, which has also got a similar compound key in. So they're all pretty straightforward. Other things that you can obviously do is you can do some consolidation of data between different data sources. So I've got a couple of examples here that take things a little bit further, but you can go as far as you want with your SQL inside of these statements. So this one is just creating a overall view of the product hierarchy from the underlying tables via joining all that information together. And finally, we've got what we call a dependent view. So we've got our large retail sale data, and we want to create a calendar. So the data within the sale data itself is just held as a date. And we might want to look up at things by week or month or year or combination. So we've used a few date functions that are available within Kognitio to create a full calendar lookup in this particular case. So there we go. So that's our views. And we can see that those are also available on the left-hand side here. Now, currently, these are all coloured up in the standard black. That means that they're not currently held in memory. They are just held as SQL statements that are executed when the views are used within subsequent SQL statements. In order to make Kognitio as performant as possible, the thing to do now is to pull these views into memory and hold these images ready for extremely fast execution of your SQL. There's a number of ways that you can pull views into memory, and what we call this is creating images. You can use console, so we can do a simple right click, create view, and we can start to decide how we're going to hold the data. So for small lookup tables such as the retail store data, we can actually replicate the image that we create. That means that a version of the data is going to be held on every RAM store in the system, which allows for very fast joins to be conducted against large lookup tables, such as the retail sale table that we've got, that we're going to create an image of in a second. So replication is for small lookups. So there we go with retail store. Now, when you create the image, the SQL that's used in the view is run, and the results are held as an image and they're pinned in memory. And you can see that console indicates this by colouring up the view in a blue colour to illustrate that it's got an image, and the little icon next to it is coloured up green. So if I just jump to the next script, we're going to do a series of those. So we've already done the store, so I've commented that out, but we can go ahead and do similar things to the other tables. So for the product hierarchy, the department, the group and the section, again I replicate the lowest level for the product as well. And if I just right click there, we can see that all those have coloured up blue. And that's reflected in our SQL actually. Okay, so for the large fact table, we're going to treat this differently. We're actually going to hash this, and when we hash an image, what this means is that rows associated with, in this case, the basket number, they'll be co-located within the RAM stores in the Kognitio cluster. What this means is that for things like views, joins and group bys, that will be that co-location will mean that they will be performed much quicker. We're also partitioning the image by sale date. This is effectively a way of telling Kognitio which bits of the image it needs to look at whenever we see a predicate that is utilising the sale date. So I'm going to go ahead and create that one. We can see that the large fact table's now back, so if we just double click on there, we can see that we've got 42 billion rows of data taking up 1.77 terabytes of the RAM that's available. So this is quite a large fact table. So let's just go back and finish off the view images. So the next thing we need to do is just run the imaging for the dates. And that's based off of the fact table. So now that's in memory. Kognitio obviously knows that. So it will run extremely quickly to get that information for those different calendar views. And then we can just step through a series of statistics gathering in order for Kognitio to run optimally. There we go. That's that complete. So now we can start doing some querying. So if I just open a SQL window, let's start with the fact table and let's just check on that row count once more. And we can see that that's 42 billion rows there. And let's see how many stores we've got that make up those 42 billion rows. And you can see all the columns that are available to us if we want to. So we can see that there's 560 stores making up our 42 billion rows. So let's have a look at a count for each individual store. Let's tidy this up a bit. Group by one, let's find out which stores are contributing most. So we're going to order by the count descending. Okay, so we're touching every one of those 42 billion rows to get this result set back, and we can see our store 539 is by far our largest store. Okay, so this is quite straightforward SQL. Let's go and have a look at something that's a little bit more complicated. So for tools like Tableau, MicroStrategy, ClickSense, the type of SQL that they will be pushing down into Kognitio will be more complicated. So this is an example that contains SQL window inquiries for those of you that are familiar with those. Let's just run that. So what's happening here, as well as the count and the sum of the value, we're actually doing some cumulative counts of those for as each week moves onwards as well. This query we start to bring in joins, so we're looking at the fact table and the product group, and we're going to look for January last year, and we're going to have a look at the sales by group, which groups of products represented the most sales by value, and we can see that actually that was the spirits section followed by the frozen meals, so there's high value items. Okay, one thing that Kognitio is really good at is the ability to do ad hoc searches in strings. So if we look at the product table here, we can start to do some sort of ad hoc train of thought analysis. So here we've got all of the products that contain the word chocolate or choc in them, and we can see those listed there. So we might, for example, want to have a look what's purchased in with Cadbury. So let's narrow this down a little bit to Cadbury. On that one, here's our Cadbury products. So let's just take that string and just copy that into this query below. So let's have a look in January, the basket count for each of the different products within the Cadbury range. So we can see that Cadbury's Crunchy Single Bar appeared in over 100,000 baskets, and so on and so forth down. So this is now moving towards typical basket analysis, so we can have a look at what was bought in with those Cadbury bars, what other products were bought with Cadbury bars for January. So this, we can build up our analytics. So if we're looking at a particular subset within our data, here we're looking at Cadbury's chocolate bars, then we can home in on whatever subset of products we're interested in, and we can join it back to the main fact table and find out everything else that was bought with the Cadbury's chocolate. So that involves joining those 42 billion rows back to each other to try and find this result. And you can see we're doing a count distinct on the number of baskets, so we can see that tinned potatoes was the highest in terms of the number of baskets that were bought with Cadbury's. So that concludes a little run through of the kind of performance you can expect with Kognitio once that you've pulled your data into memory and you've done your imaging and you're all set to go, and you can do some seriously fast querying over some seriously large data sets. So have fun.